One of the simplest questions you may face concerns the difference between constant and read-only. A great number of developers do not fully understand the difference between constant and read-only for some reason. The obvious difference is mechanical. For example, everyone knows that const is only applicable to primitive types, while read-only can be applied to both primitive and custom types such as datetime. However, the internal, so to speak, difference between them is that const variables are resolved at compile time, while read-only are resolved in runtime. This fact determines the most important implications. Look at the following example. The class defines two fields here. The first one is declared as const, and the second one is declared as static read-only. From the API perspectives, these fields are the same. However, they work differently. Consider the following two functions. One uses in its calculations the constant field, and the second uses the static read-only field. The first case after the process of compilation will look exactly like this. So, the variable was just replaced by the value. The most important distinction is that read-only values are resolved at runtime. The IL generated when you reference a read-only constant references the read-only variable, not the value. This difference has far-reaching implications on maintenance over time. Compile time constants generate the same IL as though you've used the numeric constants in your code, even across assemblies. A constant in one assembly is still replaced with the value when used in another assembly. The way in which compile time and runtime constants are evaluated affects runtime compatibility. So, the hot swap of dependencies can be dangerous in case you don't recompile the assembly, which uses somewhere constants from those dependencies. Old values will stay baked into the main assembly without explicit recompilation. However, constants have some benefits over read-only fields. The main benefit, of course, is performance. However, any gains are slight and should be weighted against the decreased flexibility. Be sure to profile performance differences before giving up the flexibility. Const must be used when the value must be available at compile time. Attribute parameters and enum definitions, and those rare times when you mean to define a value that doesn't change from release to release. For everything else, prefer the increased flexibility of read-only constants.